Not storing data in a database is unacceptable for real-world applications, since the data will be lost as soon as we close our app. In this video, I'll show you how to connect your REST API in .NET 9 to a real SQL Server database so your data actually persists. We'll also go step by step to build out full CRUD operations to interact with our data using Entity Framework Core. Island here, let's get started. So in this ASP.NET Core Web API project, up until this point, we have created a model, stored our data in a static list, and written all the HTTP methods to handle the incoming requests to our API. Now the next step would be to create a database for our project. I have already installed in my PC the SQL Server database and the SQL Server Management Studio. If you haven't though, you can just go to Google, search for SQL Server, and the first link here from Microsoft, if you click on it, you have the option to download it. You have the developer version and the express version. I'd say just go ahead and download the express version, since this is also for production ready apps. After you've downloaded it and installed it, it's pretty straightforward. Just go and search for SQL Server Management Studio, which is basically a tool that we use to help us manage our database. It should be one of the first links here, this one, in the Microsoft's website. If you just scroll a bit below, you have the option to download it right here, the latest version, and the download should start here on top. After you've downloaded this both, then just go back to your project and we're gonna create a database for our project here. If you go here on top to view, you can click on Server Explorer, and here on top where you read data connections, if you click with the right of the mouse, and you have the option here to create a new SQL Server database, which is what we're going to do. Okay, I'm gonna need to take the server name. Actually, I'll open SQL Server Management Studio here first. I'll take the server name from this. I'll just click on connect then, and I'll just go back to our project here, input the server name. Here you have the option where you read encrypt here. I'm gonna set it to false, which basically means we don't need a password to use when connecting to our database. I'm just gonna click here as well to trust the server certificate. And here we can give a name to our database. Let's name this, the name of our project was here first API underline data. That's how I'm going to name it. If you click OK, the SQL Server database will be created. And here on the properties window, you should see the connection string, which you can copy. The connection string is basically the physical location of your database, so that our project knows where the database is located. Let me close this. Now, what we'll want to do is go to app-settings.json, where we need to specify the address of our database that we just copied. Here, you need to write connection strings, and we should give a name to our connection string. I usually name them like default connection or default connection string, something like that. And here I'm gonna paste the connection string that I just copied. I'll save this here. In order to interact with our database, we're actually going to use Entity Framework Core. Entity Framework Core is a framework or tool that allows us to interact with our database using C# code. So basically any configuration that we want our database to have, or our data that are stored there, we specify inside our project with C# code, and then we migrate them to our database, and Entity Framework Core is the tool that allows us to do this. One of the first steps we need to take is to create a context class. Context classes are part of Entity Framework Core that basically make the bridge between our C# code with our database. We're gonna see how this looks like. Usually as a practice, we store this inside the data folder, this context class. So I'm just going to add a blank folder named data here. And inside of it, I'll add a class. And I'll give it a name like first API, which is the name of the project, context. Okay, this is our context class. We need to inherit here from the DB context class. Actually, firstly, we need to go to dependencies so that this class is known. We need to go to our dependencies, go to manage NuGet packages, and we need to normally install Entity Framework Core first. Okay, the first that we see here, click on install, click on accept. Okay, this was successful. If we go back to our context, now I think we just need to use Entity Framework Core on top of the page. And basically our context here is inheriting from the DB context class, which has a bunch of properties and methods that allow us to query data from our database or get data, do different kinds of operations to the data that we store in our database. Next, so that our context functions properly, we need to write a constructor here. And the constructor needs to take a few default configurations. So we'll give it this DB context options. We need to specify here the name of our context, first API context. We'll name this options as a practice. And this needs to inherit some base options. Okay, that was it for our constructor. Next, here, one more thing we need to specify in our context is that whenever we create a model, like we have here this book model, and we want to migrate this to our database, basically we want this model to be a table in our database to store our data, we need to specify a dbset instance inside our context. So if you write dbset here of type book, you usually name this a book in plural, and let's give it a getter and a setter. We need to, I think, we need to use the models on top of the page. When we migrate these changes to our database, this dbset instance will allow us to access this books table in our database and perform different operations to our data stored in it. We also need to do one last thing. We need to go to the program.cs class and we need to declare our context service here in the services container. So builder.services.add db context. Here we'll write the name of our context, which was first API context. And we need to specify some options here as well. Here in the options, we need to specify that we are using a SQL Server database. For this reason, we actually need to install the SQL Server database. Let me go back to the dependencies and manage NuGet packages. If you click here, SQL Server, this Entity Framework Core SQL Server is the package that you need to install. Click on accept. Okay, this was installed. Let me go back to our program.cs file. And here, after specifying that we are using SQL Server database, we need to also specify the location of this database, which was our connection string. To access our connection string, we need to just use here builder.configuration.getConnectionString. And here we need to specify the name of our connection string, which was the default connection, I believe. Let me close the parentheses here. And I believe on top of the page, we also need to write using Entity Framework Core. Now we are almost done. One last thing that we need to do now is to add the migrations to our database. If you want help building REST APIs or learning .NET in general, the easiest and fastest way, in my opinion, is to get direct feedback and guidance tailored to you. That's why I created the .NET Squad community, where you'll get support directly from me and other .NET developers. The best part is that you can try it for free, jump in for 1 week, explore everything, and then decide if you want to continue or not. Anyways, the link is in the description, go check it out, and let's go back to our video. A migration is basically a C# class that represents the schema of our database. So whatever data we are storing there, the relation between our data, like in our case, the model that we have created, this information is what the migration includes. And with the help of Entity Framework Core, this will then result in how our database will look like. In order to add these migrations, actually, we need to also add like a last NuGet package, which is the Entity Framework Core tools. This here, I think this is the last package we're gonna need to install, so sorry about that. Okay, this is done. Let's now add the migrations to our database. You can just go to the tools tab here, NuGet Package Manager, and click on Package Manager Console. We need to write the command add migration, and here you can give a name to this migration, like an initial migration, or let's say book model added. So what we did, what we're adding to the database by adding this migration. Okay, the migration was added successfully. As you can see here, this is the migration class. You can see that here is specified that the table will be created in our database named books with all of these columns that we have specified in our model, with an ID column, with the title, author, and the year published. Now for these changes to result in our database, we also need to write the update database command, hit on enter, and this table should be created in our database after this. Okay, if we can test this actually if we go to the SQL Server Management Studio, go to databases, and try to find our database, which was first API data, I believe that's how we named this. If you go to tables, okay, we have a books table here. If you click with the right here and click on edit top 200 rows, you should see a blank table because we haven't added any data to our table yet, but this is what we'll do right now. Now we could add some data manually in this table here, but we can do this as well inside our code, which is actually what I'm going to do in this tutorial. So let me go back to our context class. So what we're going to need to do is we're going to need to override a method from the base dbContext class. For this reason, I'm just writing here protected, override void on model creating. And this method will receive a model builder as a parameter. Next, we're also going to need to call the base implementation of the onModel creating method by just writing base.onModelCreating that takes the model builder as a parameter, so that the default configurations that this method has will still remain. And then underneath here, we will add data to our book table. We can do this by using the model builder parameter that we are taking with this method. This is a parameter from the model builder class, which actually we can use also to specify the different relationships of our entities, add data to them, just like we'll do in this case. So if we write here, if we specify here the entity, which was a book, and here we'll use the hasData method. And here I will add actually the books data that we had in our list. So if we go to the controller, I'm actually gonna take all of the books that we had in our static list, and I'm gonna store them in our database. Let me paste this here. Let's just indent this a bit. Okay, let's just close the semicolon here at the end. This, I don't think I've done any error here. So what we're gonna need to do is we're gonna need to add a second migration. So this data will be seeded to our database. So let's go to Package Manager Console, click on Add Migration. Let's name this Book Data Added or something. Okay, this is our migration class. All of this data will be added to our books table. And if we just write the command update database, hit on enter. Okay, and this seems to be successful. If we go back to our SQL Server Management Studio and click here on Execute SQL, okay, we have a table with 5 of our books with the data that we just migrated to our database. Now what we're going to do is we're going to access our database from inside our controller, so that with each REST API request that we receive in our application, we will access the database and the data will persist in our application. We will see how we can create, read, update and delete data from our database, so this CRUD operations. So let me just go to our controller here. And actually, I am going to comment this list that we have here out. And I will also comment out all of our methods that we have in the controller, since we are receiving a bunch of errors, and we will modify them one by one, so that instead of accessing the list, we will access our database. So let me comment this out as well. I'll just leave the first method that we have here. So that we access our database, we'll use dependency injection so that we access our context. Firstly, I am gonna need to have a variable here where we'll store our context. So this is what we'll use to access our context, this context variable, and we will also need to write the constructor for our controller here. And what we're doing basically is that we are setting the value of our context to this variable that we have here that we will use throughout our methods. So let's go to the first method, to our HTTP GET method. One main change that we'll do in all of our methods actually is that we will make our methods to be asynchronous, because each time we make an API call or we access the database, as in our case, we don't want the thread of our application to be blocked. If you know some apps, when you make something, you make a request and the UI stops, this is what asynchronous methods solve. So all we need to do is add an async keyword here before and wrap the result inside this task keyword, just like that. And here we won't return the books list, but we will need to await this method. We will access the context from this context variable .books, which was the name of the instance we declared in our context, .toList async. And what this does, this gets all of the books in our database. We'll test this in our HTTP file. Let me just run the application here. Let's go to our HTTP file. We already have some API calls written here. Let me get all of the data of our application. And this seems to work. We're receiving all of the data that we have stored in our database here. Now let's go back to the controller. Let me comment out the second method. Here, this will also be an asynchronous method. We need the async keyword there, and to wrap the return type in this task keyword. So I will remove this line here. The way we will access, we'll find a book. Here is by using the context, and actually we need to write the await keyword in front. So context.books.findAsync. We are using this asynchronous method. That's why we are writing the await keyword here in the beginning as well. And we are finding the book with this specific ID in the context. If the book is null, we return the not found, and then we return as a response the OK status code together with this book. That's all the changes we needed to do here. Let me run the app again and test our method. Let's go back to the HTTP file. We have an API call here that gets a specific book. Let's send a request here. Okay, we are getting the book with the ID of 2. So this works as well. Let me go back to the controller. Let me uncomment this post method. This will be an asynchronous method. Let's wrap this around the task keyword. What we'll do here is that we will add this new book to our database using the context.books. Add the new book, and we will need to save these changes to the database. To do this, we need to use the save changes async method. So up until this point, we were reading data from the database. Now that we are performing an operation to the database, after we do this operation, we need to save these changes with this method. And that's it for this second method. Let me run the app, go to the HTTP file. We have a post API call here. The only change I'm gonna make here is that I'll remove the ID here because this will be generated automatically. And I think you'll receive also an error when you try to put the ID yourself in this case. So let me send the request. We received the 201 created status code. This was the book that we added to our database, and we can test this in our database. If we go to our database, click here on execute SQL. So we can see this data was stored in our database. My book here with an ID of 6. So this also proves that this is working. All of our data persists now in our application. Let's go to which is the next method. We'll need to uncomment here. Okay, this is the put method. This will be an asynchronous method. Okay, I will actually copy the code from here on how we find the specific book in our database. Let me paste it here. And I'll leave the rest as it is, other than after we change the data. We're gonna need to save the changes with the save changes async method. I'm gonna need to run the app and go to our HTTP file here. Where was our put request? Let me get all of the data first to see what we have here. Okay, I'll change the last book that we added, C#. Let's just change the name here, C# ebook from me 2024. If we make this API request to our REST API, okay, we receive an error. This is my bad. We are making the request to the wrong ID here on top. The book's ID is 6. This is the issue. If we run this again, okay, we receive a 204 no content response type. If we check now to get all of our books, the 6th book here, the title was changed. We can go to our database and check here as well. Okay, the title of my book here was changed in the database as well. So this is all working. Now let's just go and change our last method, our delete method here. Let me uncomment this. This will be an asynchronous method. Let me get this line again. I'm just feeling lazy. Okay, we will remove the book here by accessing the context.books. Remove. We as well need to save the changes since we are performing an operation to our data in our database, and that is it. If we run the app now, let's go to our HTTP file to test this. We have an API call here. Let's say we want to delete, let's leave it like that. We want to delete the book with the ID of 4. If I send the request, 204 no content response type. Let's go to the database, execute SQL, And as you can see, the book with the ID of 4 was deleted. We do not have it here anymore. Hopefully this was helpful. You can now build a REST API, make the data persist, connect the project to a database, and perform all of the CRUD operations. To build on what you learned in this video, the video on the screen is the right next step. So click on it. Thank you for watching, and I'll see you there.